Today we're starting with multiplying, dividing, rational expressions. So far today it's kind of gone through without too much of a hitch. The one problem you will come across that people forget are some of the rules with sums and differences of squares, or sums and differences of cubes. So what we're looking at here today is basically factoring, and simplifying with your exponent rules. For example, if I start out with a problem like this and I need to simplify, you will notice that it's a trinomial over a binomial, which is basically written as a fraction. When you simplify fractions, you're looking for common factors. Remember that? If you were going to simplify 4 over 6, you would divide both the top and bottom by 2. If you had 4 over 6, you would be able to rewrite that as 2 times 2 over 2 times 3. And you simplify it out like that. We basically are going to do the same thing, but in terms of factors. So every time you see something where it says simplify or multiply or divide, when you get to those trinomials, I wouldn't even bother starting to write out the trinomial, knowing that I'm going to have to factor it right away. I just start factoring it. So what times what's negative 12 here? You add together to get negative 4. Yeah. Oh, no. I was saying what we're doing is basically this same thing of simplifying fractions. How we simplify fractions. It's no, it's okay. So in this case here, what times what's negative 12? You add together to get negative
2 negative 6. If you're lucky.
And then if you factor the denominator, what do you get? What's that? Negative. Yeah.
2 minus 2
And?
x plus 2.
There you go. So when you factor the denominator, it's the difference of squares. So you have x plus 2x minus 2. And now you're looking at what simplifies out. What can you cross off? X plus 2.
Oh, that's cool.
And you're left with
Don't laugh.
x minus 6 over x minus 2. Can I go any further? Nope.
That would do it.
I cannot simplify this any further because now I have it in terms of there is subtraction involved. There's addition involved. I cannot simplify over addition or over subtraction. The only time I can do this simplification like this is when I have multiplication here. Those are two terms being multiplied together. It's of the same premise that I was showing you guys of 4 over 6 being rewritten as 2 times 2 over 2 times 3. I can simplify it that way. It's the same basic idea, but you're using it in terms of factors. Okay? Again, as you go through these types of problems when you're talking about simplifying, multiplying, dividing, whatever, don't take the time to write out the problem, because you're going to be looking at it in your book, you'll be looking at it up here. Just start by factoring right away, if you can. Okay? The other one that we're going to look at is going to be stuff like this, where we're multiplying. Now, again, when you're multiplying, or if we had to divide monomials like this, we've done this before. We did this back in chapter 6 with our exponent rules. We did that in chapter 7 with our exponent rules that had negative exponents, or fractional exponents. All of those same exact properties and everything still hold true today. In this example, what I'm looking at here, you'll remember when we did this before, my rule was always to start with the numbers. Start by working your numerator together. Multiply stuff out. Then go to your denominator, multiply stuff out. After you go through those, that's when you would simplify. Try to do it in smaller chunks at first so you don't make the silly mistakes. For example, in this case here, if I'm dealing with my numerator for my numbers, what's 6 times 5? 30. Now go variable by variable. I have x squared times x cubed. What do you get?
X to the
Good. Y times y squared. Very good. Denominator. 2 times 10.
1.
I have just the x and y to the 4th. The next step from there was then to simplify out, and this is when you would have to play that game of war. Remember that? Who wins, that's where the values are going to stay. Now, the real tough one here is 30 over 20. All right, it's 3 over 2.
Oh, you can just move from 0 to
Yeah, 3 over 2. Now who wins? X to the 5th or X?
X to the 5th.
So what's 5 minus 1?
X 4.
And since, remember how the rule was, since the 5 is in the numerator, it wins, the value stays up top. The next one, we have a 4 and a 3, who wins? Yeah, yes, the Y wins, very good. The 4 wins, so where does the Y go? And you're done. Okay? You all right? Don't get angry, it's just math.
Oh no, she just said she doesn't like fun.
Mubby, herpy. Huppy.
All right.
Everyone just no.
Again,
Sorry, I wasn't angry. She asked me why I walked back.
do something better.
I watched every single movie.
Why does it surprise me? Again, as you start these problems out, guys, don't write down the problem as 4x minus 4x squared. What are you going to do with that numerator?
A little too late for that.
All right, if you have not written anything down right away, since you know you're going to have to factor as you're going, how do you factor this numerator? What's the rule?
Let's multiply oil.
No. What's the first rule of always factoring?
Right?
What's the GCF there?
2. We just got off of 2 and 2 snow days. 2
I'm trying to talk a little slower. Doesn't work for me. What's the GCF of 4x and 4x squared? 4x. So I factor out the 4x, I'm left with 1 minus x. There's the first numerator. What times what's negative 3? You add together to get positive 2.
Wait. Oh.
I'm just factoring. I'm not writing down the problem. I'm just going.
1 and 2 and negative.
What times what is negative 6 to add together to get positive 1?
Negative 3.
Very good. Can I do anything with the 4x? Bless you.
You can,
Now, from this point is when I can start seeing what simplifies out. What do we have in common in the numerators and denominators? 4x.
Oh, it's okay. Because I guess it's multiple. Cross multiply.
I'm not cross multiplying, there's no equal sign.
So x plus 3. Oh, you already got it.
And I'm done.
Wow. This is a fair game.
Oh wait, you're
Because it's just multiple.
Since I'm multiplying, remember when you're dealing with fractions, when you're multiplying fractions together, the numerators all stay together, the denominators all stay together. It just becomes one giant fraction bar. So you're looking to see which sets of them simplify out. You're looking for groups of 1. X plus 3 divided by x plus 3 is 1. 4x divided by 4x is 1. Those get dropped out. Now, I cannot simplify 1 minus x and x minus 1 because they're not the same. Come on. This has all come up a couple of times today as well. Do I need to FOIL out that numerator for my final answer? No. Don't waste your time. Sometimes, I think the book does. I think it's pointless. There's absolutely no reason to do it. Okay? And that's your answer. Just leave it. Okay? Try this one. This is one of those special patterns you have to recall. Maybe on one of the boards up here somewhere. I don't know.
Oh, up there?
That most of you guys have forgotten.
Oh,
What's the value of a in this case?
2. 8x.
2x.
Oh, I
Remember, it's the first term is 8x cubed.
Oh, because 1 times 1 is 1. That's why I was like, yeah.
So the value of a in this case is 2x. The value of b is 1. So what you have to remember is how to factor out a difference of cubes. In this case, you just follow the pattern. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. Remember, it's always the same sign, change sign, positive. If you look on the board again, difference of cubes, same sign, change the sign, positive. Sum of cubes, same sign, change the sign, positive. Every single time, it's the same pattern. So when you start writing all that out, your numerator stays x plus 3. Your denominator becomes 2x minus 1 times 2x quantity squared is 4x squared plus 2x plus 1 times and do I change anything by putting that over 1?
No.
Nope. What drops out?
Oh, that's wild.
That whole chunk drops out. And you're left with x plus 3 over 2x minus 1. Again, this is an exercise in knowing and remembering how to factor. Factor, factor, factor. Okay. Can't simplify it any further. There's no other GCFs. There's nothing else that we can do. Can't take anything else apart on that one. And I'm done. Okay. What changes with division in this stuff? Do you remember? How do you divide by fractions? Multiply by the reciprocal. So how would you divide by the crazy stuff? Yeah. Yeah. In this case, again, if I'm going to divide, when I start to write these out, I'm always going to multiply by reciprocals. The numerator, the first part, stays the same. Remember, when you're dividing, you're multiplying by reciprocals. Now, I know a lot of you guys are already sitting there writing this stuff down. If you remember that when you're dividing problems out, and you know that you're going to multiply by a reciprocal, and you know that you're going to have to factor, could you just start factoring and multiply by the factored terms as you're going? It works just the same. If you want to write out all the steps, that's fine. All I'm doing is trying to save you guys some pencil lead. So as you go through, can you simplify anything out of the 5x? No. Nope. What do you do in the denominator there? Take 3 up. What times what's 8? You add together to get -6. And what can you do in that denominator? And now the fun part. What drops out? X minus 4s. X minus 2. Anything else? The x's. And there's your answer. Everything drops out except for the numbers. It is possible that when you factor these things out, nothing drops out. It is possible that everything drops out. If everything drops out, what are you left with?
1.
Very good. You're left with 1. You're not left with 0. You're left with 1. Because as you go through, if you have, let's say this was 3x over 3x minus 4 times x minus 4 over x. You agree that in this case here, that the x minus 4's go away. The x's go away. What's 3 divided by 3?
Or would the threes go away?
What's 3 divided by? What does that mean though? Because think about this. What's x divided by x? 1.
Oh, okay.
X minus 4 over x minus 4. 1. 3 over 3.
So really you're just getting a bunch of ones?
Yeah. You're pairing out ones. If that makes sense on that one. Yeah.
Alright, this is gonna be a really tough.
It's not a really dumb question.
Okay, so you know how like at the beginning you were dividing it, but then once we factored it out, we were multiplying?
Yeah. Because whenever you're divided by fractions, you always multiply by the reciprocal. Don't ever divide by a fraction. It's nasty. You always want to rewrite it as multiplying by a reciprocal. Okay? You can say, no, I can't do it because you said it's nasty. Excuses. You're trying to get out of everything, aren't you?
Maybe.
All right, try this one then. Again, in this case, you have to remember how to multiply, how to factor stuff with leading coefficients not equal to 1. How do you factor with leading term coefficients not equal to 1? How do I factor 6x squared plus 7x minus 3? What do you do? You can't.
So you multiply.
Good. What do you get? What times what's negative 18? You add together to get 7.
9 and negative.
Good.
Oh.
This is where you're going to do that split middle term,
Yeah.
so you can factor by grouping. So you're right. You wind up with 6x squared minus 2x plus 9x minus 3. Does it matter the order that I put the negative 2x or the plus 9? It doesn't. My trick was always to put the negative value first if there were alternating signs. It's just a little bit cleaner. You don't have to. It's just a little trick. Now you have your grouping that you have to do. You're looking for GCFs in both of these sets. That first group, what's the GCF of 6x squared and 2x? Factor out the 2x, you're left with 3x minus 1. After that, what can I factor out of the 9x minus 3? Just the 3, so that way you're left with. So now all that work to factor the numerator now gives me the term of 2x plus 3 and 3x minus 1. That gives me my middle, or how my setup works. Can I factor anything in the denominator of the 6x squared? Nope. This is the same thing as dividing by 2x squared plus 3x over 1. Do you guys agree?
Yeah.
What's the reciprocal of that?
1 over 3.
Bless you. So when I do the reciprocal here, I get times 1 over. How do I factor the 2x squared and the 3x? What can I get out of there? Take out the x. From there, you will be able to simplify out. What simplifies out? The 2x plus 3 goes away. And is there anything else that I can do? No. So when I final answer here, when I rewrite this out, it gives me 3x minus 1 over, well, what's 6x squared times x? 6x cubed. And I'm done. I cannot simplify any further. All right? Nothing else drops out. Oh, yes, you're right. It's been like 20 days. Yes, sir.
Wait, why did you switch from the numerator?
I'm dividing by this, so I multiply by the reciprocal. If you divide by 2, is it the same thing as multiplying by 1/2? Same idea. What we're doing here, we're dealing with all these terms like this. It just makes your life so much easier to always rewrite by multiplying by the reciprocal whenever you see the division sign. Okay? All right, take a minute and do this one. Oh, wait, not this one. That's not what I need to do. Yeah, I'll do that one. That goes away, this goes away. You're left with x over 3x plus 5.
Oh, I know why you got that. I understand the nail.
Yeah, I pretty much got it.
What happened?
That piece of you didn't write x squared. You squared out 9x squared is 3x. Square root of 25.
It's like you tell
is
people
3x
that
minus 5
you
plus
have
5.
to touch it to make sure. And you tell them
Welcome back.
okay.
You're welcome. Let's see. I'll give you one more, and we'll call it a day.
Thank you.
Let's see, 5x.
Mr. Murphy.
I was in the zone.
You don't have me giving my
All right.
You keep putting a shadow over
Yeah, you're right.
Wait a minute,
What?
I factored them when I got 5x times 3x plus 3 times x plus 3.
So it's
I
1
got a trinomial.
No.
I wasn't supposed
Where?
to.
Here?
No, on the 15x cubed plus 4.
What's the first rule of factoring?
Good luck.
Take out this stuff.
Okay, take out the GCF. You have 15x squared times x plus 3.
Yes.
I took out 5x.
That's wrong. You're wrong. It wasn't the GCF then. So you're left with 5x over 15x squared, which gives you 1 over 3x.
What? Wait a second.
What do you mean, what? Wait a second. 5 over 15, 1/3. X over x squared. X.
Card game.
So you.
I got 1 over 3x plus 3.
Yep.
I was.
Yep. Which simplifies out to be 1 over 3x.
I'm classing.
Versace, no homework would be great now.
It's 131.
It's a whole whopping 9 problems. I think you can do it.
It says 1.
All right.